Welcome back. So today we are going to study complex numbers. So first we consider the number that raised to the power of 2 equals minus 1. So this number is written I, okay, that you see right here. Okay, so I square equals minus 1. And from this number we are going to build an entire new space of numbers called the complex numbers. And we are going to write those numbers as z equals a plus I times b, okay, with a and b belonging to R, which is the set of the real numbers. Okay, so a and b are real numbers. Okay, so complex numbers are a plus I times b. Okay. So for example, every real numbers are complex numbers because, for example, let's say 1. So 1 can be rewritten as 1 plus I times 0. So we would have a equals 1 here, a equals 1, and b equals 0, excuse me, b equals 0. So every real number is a complex number, but of course it's not the other way around. Okay, not every complex number is a real number. Okay, so for example, I is not a real number. Okay, so the set of the complex numbers in the set of complex numbers there is the set of real numbers. So now let's move to the third property here. So we can rewrite a complex number in another form called the exponential form. So if we have a complex number z equals a plus I times b, we can rewrite it as rho multiplied by exponential raised to the I times theta, okay, with rho is a real number and theta is an angle in radian. Okay, so here there is a little graphic here. So this is called the complex plan. Okay, so in the complex plan you have two axes. You have the imaginary axe and the real axe. Okay, so if we take a number is in the complex plan, let's say z, z equals to a plus I times b, like we said earlier. So a, you can see the real part, which is a, which is called the real part, and the imaginary part, which is b, on the axes. So this is a here on the real axe and b on the imaginary axe. So rho represents the distance between the origin of the plan and z. So this is a distance, so it's always positive. So here it belongs to R plus, and theta is the angle between the real axis, okay, and the segment in green here. So, for example, I is 0 plus I times 1. Okay. So 0 is the real part and 1 the imaginary part. And if we want to rewrite I in the exponential form, it would be I equals 1 times e to the I, and the angle theta would be pi divided by 2. Okay. Because this angle here, so I'm going to remove this. So on the complex plan, I would be, let's say here, it would be I. Okay, so the real part is 0 and the imaginary part, okay, is 1. So this is 1 here. Okay, the distance here is 1. Okay, and the angle, so this angle would be in radian pi divided by 2. Okay. So, and last important property to know is that exponential raised to I times theta can be rewritten as or expressed as being cos theta plus I times sinus theta. Okay. So here I have written that cos theta is A and sin theta is B, but in reality here it's a mistake. We have rho cos theta equals A. And rho sinus theta equals to B. Okay, because when we write, so let me erase this. So when we have z equals rho e I theta, which is equals to rho times cos theta plus I sinus theta. We can distribute here the rho. We have rho cos theta plus rho plus I rho sin theta. And we can identify the imaginary part and the real part. So the imaginary part is here, the real part is here, so this is A, and the imaginary part is here, this is B. Okay. So that's it for today. I hope you enjoyed the video. This lesson on complex number is preparing future exercise involving complex numbers. So boop the like button and subscribe. Goodbye.